Hi, my name is Jesus Daniel Benavente, and my experiment was about hydraulic power in hydraulic presses. This research had the purpose to better explain and comprehend the physical phenomena of an uncompressible fluid and how this specific property can multiply force. So, all fluids are technically compressible, but some have a almost infinitesimal amount of density change when in the presence of pressure. And when this happens, you can say that the rate of change in density of a fluid is zero. So when a fluid is under pressure, the pressure expands in the chamber that is in with the same amount of force, but in with if the area is different, the forces will multiply. So if we go back to the past image, we can see that the pressure will be the same. But if you press down on this side of the piston, since the pressure will be the same, also in this side, uh, since it has a bigger area, more water or more fluid will be pushing against this piston, so it will have more force. Uh, and the studied variables were the area between the two pistons, because if you have two pistons which have the same diameter, they will multiply the force by one, so the forces will be the same. Also, the type of fluid, since some fluids are compressible, such as air, and and how it affects the results. The dependent variables were the forces that were the output, the distance that the piston moved, and the control variables were the temperature and the atmospheric pressure, which didn't change. So the experiment was two repurposed syringes, like in this image, with different diameters. One with smaller diameter than the other one, and the fluid was passed through this tube to the other side. So when you press down on one piston, the fluid will travel through this tube to the other piston and multiply the force or multiply the distance, depending on which side of the piston you were pushing. Okay. The results, the raw data was when 700 grams, the force, to apply force, a constant force, I use a weight, in this case, a 700-gram weight. And when it was placed on the bigger piston, it pushed the other piston when it had no weight. And also vice versa. When I put 200 grams in this side of the piston, uh, it moved the other piston when it had no weight in this side. And to prove that the equilibrium of 3.5 times the force was kept, uh, when the two weights were put one against the other, the forces were equal, so it stayed balanced. And it did. As predicted, the two weights were static the 5 minutes that they were untouched. And so the theory stays proven. But it is interesting to note that when you push in the smaller piston to push a heavier weight, you don't feel a force, but rather a small weight on the other side, and you can feel like you can push almost everything. Nothing seems out of reach. And when you try the other way around, so you push in the bigger piston, everything feels so heavy. And I know this isn't quantitative, but it is an interesting observation. So I put this image here that you feel that you can carry the world, basically. These are the reference, and thank you.